Hey everyone, and welcome back. We're diving into some really cool battery tech today. Um, I recently listened to this episode of Cocktail Party Chemistry, episode 89, and it really got me thinking. They were talking about solid electrolytes
Oh, yeah.
and how they could be like the key to making batteries safer. You know, we've all heard about those scary phone battery fires, right? So,
Right.
like, is that what they're trying to prevent with this technology?
Yeah, definitely. That's one of the big things. Solid electrolytes, they basically tackle those risks head on. The risks you get with the liquid electrolytes, like the leakage and flammability. I mean, those are some of the biggest concerns with conventional batteries.
Okay, so that makes sense. But how do these solid electrolytes actually work? It all sounds a bit like, I don't know, like something out of a sci-fi movie.
Well, it's actually not that complicated. Think about a normal battery. You've got charged particles moving between the electrodes, and
Right.
those are called ions. And they move through a liquid to create the electrical current. That's how it works.
Okay, yeah, I remember that.
Solid electrolytes just swap out that flammable liquid.
Yeah.
They replace it with a solid material that can still conduct those ions.
Oh, I see. So instead of a liquid, it's a solid, but the ions can still move through it.
Exactly.
So it's like they're paving a super smooth highway for
Yeah.
those ions to travel on.
Yeah, that's a great way to think about it. The smoother the highway, the better the battery works. And, that ability of the solid material to conduct ions, that's what we call ionic conductivity.
Ionic conductivity. Got it.
And that's a really big deal. It determines like how efficient and how powerful a battery can be.
So the higher the conductivity, the better the battery.
Absolutely. Scientists are always looking for materials with higher and higher ionic conductivity to make batteries even better. And that's where things get really interesting. They're looking at all sorts of materials, ceramics, polymers, and even combinations of both called hybrids.
Okay, hold on. So ceramics, polymers, hybrids. What are the pros and cons of each one? Is it kind of like choosing the right tool for the job?
Exactly. You got it. Each material has its own strengths and weaknesses. So, for example, you have ceramics.
Okay.
It's super stable, great ionic conductivity, but they can be a bit brittle. So that's not always ideal if you need something flexible.
So if I drop my phone with a ceramic electrolyte battery, it could crack.
It's possible, yeah.
Yikes. So what about polymers then? They're probably more flexible, right?
Yeah, polymers are much more flexible, so they're good for wearables, flexible displays, things like that.
Excellent.
But they sometimes don't have the same level of conductivity as ceramics.
So it's a trade-off then.
Yep, stability versus flexibility. It's
Yeah.
a balancing act.
I see. And then there are the hybrids. So those are like the best of both worlds.
That's the idea, trying to combine the high conductivity of ceramics with the flexibility of polymers. That's kind of the holy
The
grail.
holy grail of battery technology.
Yeah.
So, like, scientists are on a quest to find this perfect material.
Yeah, pretty much. It's this constant search for better materials and better designs. And that's what's driving the amazing progress we're seeing in batteries. But it's not just about making a better battery, it's about what we can do with it.
Right. Like what it could unlock for us. I remember the episode talked about electric vehicles and grid storage, right?
Yeah, exactly. Those are two huge areas where solid electrolytes could make a big difference. Think about electric cars that could go so much farther because they have higher energy densities.
No more range anxiety.
No more range anxiety.
Sign me up.
Eh.
What about grid storage? I'm not as clear on that one.
Well, think about all the renewable energy we're trying to use.
Mhm.
Solar power, wind power, that kind of thing. They're great.
Yeah.
But the problem is they're intermittent. Like the sun isn't always shining, the wind isn't always blowing.
Right. It's not always consistent.
Exactly. So we need a way to store that energy for when we need it. And that's where solid-state batteries could be a real game changer because they're safer and they could last a lot longer than traditional batteries.
So we could have a future where we're running on clean, renewable energy stored in these super safe, super efficient batteries. It sounds almost too good to be true.
It's definitely exciting, but it's not all smooth sailing. Remember ionic conductivity?
Yeah.
Well, even with these solid electrolytes, it's still a challenge to get the conductivity high enough.
Oh, so even with the solid stuff, they still have to work on making those highways smooth enough for the ions.
Exactly.
Okay, so there are still some roadblocks. Interesting. I'm definitely curious to learn more about those challenges and what they're doing to overcome them.
Well, get ready, because we're just getting started. There's a whole world of exciting research happening in this field. So, we were talking about those roadblocks. Well, actually, some really interesting research is happening because of them.
Oh, really? Like what?
Well, remember how we said scientists are looking for that, perfect material? One with high conductivity, A and D flexibility?
Yeah, like the unicorn of battery material.
Mm-hmm. Right. Exactly. And to do that, they're having to get really creative. Like they're trying all these different things, different ways to make the materials. They're even using nanomaterials now.
Wait, nanomaterials? Those super tiny particles. I don't get it. What do those have to do with batteries?
Well, think of it like this. When you get down to the nanoscale, materials start acting kind of weird. They don't behave the same way they do when they're bigger.
Oh, okay.
So by using nanomaterials, scientists can like fine-tune the properties of those solid electrolytes.
Huh. So they're like manipulating the material at the tiniest level to get exactly what they need. That's so cool.
It is pretty wild. And it's not just about the material itself. They're also looking at like the whole structure of the battery, the design, the architecture.
Wait, designs and architecture. I thought we were talking about batteries, not buildings.
Huh. Well, yeah, it's a bit different. But the way a battery is put together inside can really affect how it works. For example, some scientists are developing these thin film batteries. They're super thin and flexible.
Oh, I bet those would be perfect for wearables, like smartwatches and stuff.
Exactly. Or even things like medical implants. Imagine that. A battery so thin and flexible it could be inside your body.
Whoa. Okay, now my mind is completely blown. This
No.
is all so futuristic. But, I mean, with all this amazing research happening, what's the big picture? Like, what kind of impact could these solid-state batteries actually have on the world?
That's the big question, isn't it? And I think the impact could be huge. Like we talked about electric cars and grid storage, but think even bigger than that. Imagine a world where portable power is completely safe, reliable, always available.
Wow.
It could change everything. Healthcare, disaster relief. I mean, the possibilities are endless.
Yeah, I see what you mean. Like medical devices that never need their batteries replaced,
Mm.
or like portable power sources that could help people after natural disasters.
Exactly. Or in developing countries where access to electricity is limited, solid-state batteries could provide a clean and sustainable energy source. It could really empower those communities.
That's incredible. It's like a ripple effect, changing things on a global scale.
You're right. It's not just about the technology, it's about how we use it to make the world a better place, to solve real problems.
That's a really good point. It definitely makes all this talk about batteries feel a lot more meaningful. But I guess we can't get too carried away. The episode also mentions some challenges, right? Like things that are preventing this technology from taking off right now.
Oh, yeah, definitely. There are always challenges with new tech. One of the big ones is cost. Making these solid-state batteries, especially on a large scale, it's still pretty expensive compared to the regular batteries we use now.
Ah, so those super safe, super efficient batteries are going to come with a super high price tag.
For now, yeah. But like with any new technology, the price usually comes down over time as they figure out how to make them more efficiently.
Right, like flat screen TVs. They used to be so expensive, but now pretty much everyone has one.
Exactly. And it's not just the cost. There are still some technical hurdles, like
Yeah.
how to improve the connection between the solid electrolyte and the electrodes.
The what? The electrodes?
Yeah, the parts of the battery where the current flows in and out.
Okay.
That connection, the interface, it needs to be really strong and stable. Scientists are working on ways to optimize that.
Oh, I see. So it's kind of like building a bridge. You need a really solid connection on both sides for it to work properly.
Exactly. And then there's the issue of durability. You know, making sure these solid electrolytes can handle the wear and tear of real-world use.
Yeah, especially if they're going to be in things like electric cars. They have to be tough.
Right. Heat, cold, vibration. Those batteries have to be able to withstand all that.
Sounds like a lot to figure out. But it's amazing how much progress they're making. I'm curious, where is all this research happening? Are there any universities or companies that are leading the way?
Well, it's not just one place. It's happening all over the world. In the U.S., you've got places like Argonne National Laboratory
Oh, wow, yeah.
and MIT. They're really pushing the limits.
Yeah, those are like the big leagues of research.
Yeah, for sure. And then you have companies like Tesla, Samsung.
Oh, right.
They're putting tons of money into solid-state battery tech.
Makes sense. I mean, they'd benefit a lot if this tech takes off.
Oh, yeah, absolutely. But it's not just the big companies. There are tons of smaller startups, too, all trying to crack the code.
Wow, so it's like a race to the finish line.
Pretty much. Everyone wants to be the first to have a solid-state battery you can actually buy.
I can imagine. It makes
Yeah.
me wonder, though, I mean, we've talked about all the good things, all the potential, but are there any downsides? Anything we should be worried about?
Yeah, that's a good point. I mean, every technology has its downsides. One thing to think about is the environmental impact, like mining the materials for these batteries.
Right. Some of those materials are pretty rare, aren't they? Like, isn't it hard to get them?
Yeah, exactly. So we have to be careful about that. Make sure we're mining them in a sustainable way,
Mm.
not causing more harm to the environment.
Right, it's like we don't want to solve one problem just to create a new one.
Exactly. And then there's the whole issue of jobs. I mean, if these solid-state batteries become super common,
Yeah.
what happens to the people who work in the regular battery industry?
Oh, right.
It's like any big technological change, there are always going to be some people who are negatively affected.
It's tough, but I guess it's kind of inevitable, isn't it?
Yeah, it's the nature of progress, I guess. But the good news is new technologies also create new opportunities.
Right.
So there will be new jobs, new industries popping up around these solid-state batteries.
So it's all about adapting to the changes,
Right.
figuring out how to make it work for everyone.
Exactly. We have to find ways to make sure everyone benefits, not just a few people.
Well said. This whole conversation has been so interesting. I feel like I've learned so much about these batteries.
Me too. It's such a fascinating area of research. And who knows what the future holds, you know? There could be even more amazing breakthroughs just around the corner.
It's pretty exciting to think about. Thanks for taking the time to explain all this.
Of course. It's been my pleasure. And to all our listeners, thanks for tuning in. I hope you learned something new today.
Yeah, and who knows, maybe one day we'll all be using these amazing batteries in our everyday lives. Until next time, keep exploring.